Hello and welcome to another episode of the New Weight Paradigm with me, your host, Deanna Bedoya. And in this podcast / YouTube web series, we are changing the narrative around weight and weight management, and ideally getting us to a place where we feel really confident about our eating and movement decisions and feel really great about the body that we have been blessed with and that we get to work with to not only achieve health, but also to achieve like an amazing existence in this life. This podcast is about confidence. This podcast is about feeling just great in your own body and challenging all the messages out there that suggest that we shouldn't and that we're not good enough the way we are. So that's a goal of this podcast. Like I mentioned, my name is Deanna Bedoya, spelled Diana. And I'm a senior lecturer at Simon Fraser University. This work is separate from that. And what else do I do? I'm a coach. I'm an educator. I am a speaker as well. And I've also struggled a lot with my weight in my life. So that is something that I feel very connected to. This subject I feel very connected to, and is something that I really want to help people feel a lot more empowered about and feel a lot better about with respect to their own lives. So in this episode, I want to start talking about one of my favorite parts of the body, possibly my favorite part of it. No, it is my favorite part of the body, which is the just beauty that is the human brain. And as wonderful and magical and like unknowable really that the human brain is, the way our brains are structured and the way our brains are worked, for some of us, though, this structure and function of our brain might potentially set us up for overeating. Okay, so a lot of the newer narratives around obesity and weight, and for scientists that actually study this, you'll often hear the words obesity is a brain-related disorder. We often think of obesity or weight management issues being all about like self-control and willpower and whatever else. But I think it's important to really understand that there are a lot of factors going on in the way that our brain is structured and the way that our brain is work that promotes a way of eating in particular. It's mainly a way of eating that promotes a way of eating that is causing us to be larger for some people. And for other people, it's the opposite. For other people, the way their brain is structured and the way their brain is functions is structured in a way that it helps to promote lower food intake. Okay, and it's not just the brain that's involved, because the brain doesn't work in a vacuum. And the human body is very complex, and there's all this feedback that's going on to the brain, back to the brain about what's going on in the body, etc. But at the end of the day, your brain is your drive center. It's the thing that's going to drive you to want to eat, just like it drives you to want to drink water, right? Or drives you to have to go to the washroom, or drives you to want to have sex, etc. Your brain has this drive center in it, and it also has a decision-making system in it too. That's being affected by all these other things that are going on around your body, but that ultimately that drive center and decision-making center, which work together, ultimately determine what we eat. So if we want to understand why we eat the way we do, we also have to understand how our brains work with respect to food intake, which is the goal of today's discussion. Okay, so just to give a little bit more of like evidence base to what I'm talking about when I say that obesity is a brain-related disorder, is evidence from what's called Genome-Wide association studies. So Genome-Wide association studies, they're so fun. They're like really interesting. I find them so fascinating. So with our ability to like map the genes that a human has, and our ability to map like changes in genes, changes in the genetic code of certain genes in our body, and how these changes show up differently in our population. With this ability of modern science, we actually have huge databases around the world of genetic data for people. Like we know, like, you know, what your DNA looks like, basically. Okay, so we know what your DNA looks like, and we know where there's been changes in certain people's DNAs. Okay, DNA. So what a genome-wide association study does is it says, okay, well, I have all this data about genetic profiles of people, and I also have data around like body size. Can I map the two? Can I say, okay, can I look at people with obesity? This is where I'm going with this. Can I look at people with obesity and say, well, we know these people, we have genetic makeup for these people with obesity. What is different about their genetics? What is different about the genetics of people with obesity compared to people that don't have obesity? Okay, so that's what they've done. And without like trying to tell the data what to do, just letting the data speak for itself. And so these genome-wide association studies is part of something called the GIANT trial, the Genetic Investigation of Anthropometric Traits Study. I think that's what GIANT stands for. This GIANT study, which is a genome-wide association study, they mapped BMI and they mapped to like genetic makeup of an individual. And what they found is that there are more than 100, at least around 100, but likely more than 100 specific places in the human genome that are more likely to be different in individuals with obesity. So put a different way, there are, well, from the 2015 study, they found that there was a total of 97 genetic loci, places, where there are changes, or what we call single nucleotide polymorphisms, or SNPs as they're sometimes called, that are more likely to show up in individuals with obesity than in individuals that don't have obesity. Okay, so what does this have to do with overeating in the brain? What's fascinating is that these researchers, if you hear them talk about it, they said that like they were actually expecting that these genetic changes would be found in and around genes that have to do with like metabolism or fat storage. But what they actually found is that the majority of the genetic changes that are more likely to be found in individuals that are in larger bodies happen around genes associated with the brain and nervous system. And what's the most fascinating about that is that the majority of those genetic changes that are more likely to be seen in individuals with obesity, the majority of those changes happened in and around genes that are associated with appetite. So when I say that obesity is a brain-related disorder, what I'm actually arguing is that certain people have changes in their brains that may increase their likelihood to eat more. And you know, I didn't need a genetic study to tell me that. I, from a young age, haven't understood why I always want to eat. Whereas I looked at my friends and I was like, they don't have the same drive. Even when I was like 10 years old, I always had this drive to overeat. I remember just like crying about like, why don't I feel full? Why can't I stop eating? Why do I have this like drive to consume that other people don't seem to have? And, you know, some people just want to pass that off as willpower. Sure, whatever. Self-control, sure, whatever. I have those things. But what we're really finding now is that there are changes in the way that the brain is structured, and there's changes in the way that there's signaling to the brain as well that makes it so that some people always feel a drive to eat compared to other people. Okay, so that's what we're going to talk about when we talk about overeating in the brain. But it's really important, as I start talking about like brain regions very lightly, I won't go too far into things. It's really important to remember that brains are highly complex and no single part of the brain works in a vacuum, works on its own, right? Everything's highly integrated, and that's why it's so hard to unpack some of this research, because it's like, you don't really fully, it's really fully hard to understand exactly how all of these things work together. Okay. But we do know that there are a bunch of different brain regions that are involved with the regulation of our food intake. Okay. The regulation of our appetite, which is our drive to consume, and the regulation of our food intake accordingly. Okay. And if you're watching this on YouTube, you see on your screen this like map of some of the brain region. This is actually from an older article, The Neuroendocrinology of Appetite. I think it's 2006. Oof, I didn't put the date on there. But anyways, where it shows some of the major brain regions that are associated with eating. And there's, I don't know, there's 20 on the screen, and you see lots of interactions between them. Okay, so we're not going to unpack this diagram because I don't have the time or the energy to do so. But what I want to do today is differentiate between the factors that cause us to eat in a way that promotes kind of a healthy balance of energy intake and energy expenditure, and the factors that make us eat beyond that. So, one of the ways we can talk about eating behavior is with the concept of what we call homeostatic appetite. So when you think of homeostatic appetite, like it's the type of eating pattern or drive to eat that's all about keeping things balanced. That's all about making sure you don't gain too much fat. That's all about making sure you don't lose too much fat. That's all about making sure you have enough nutrients to do the things you need to do. Right? Homeostatic appetite, we often liken it to like a thermostat, right? And you could argue that it's trying to keep your nutrient levels and energy levels at a particular range. And then if you go beyond that range, there's feedback to your appetite centers in your brain that tell you, well, you ate too much, you have a lot of nutrients, eat less. Okay? Or your fat cells, they're really depleted, eat a bit more. Okay, so there's that feedback system that helps to typically keep things in balance. And if you talk about something like body set point, you could argue that that speaks to this homeostatic appetite. Okay, so think of homeostatic appetite like you haven't eaten all day and you feel hungry. That's homeostatic factors that are trying to keep things balanced to make sure you get enough of the nutrients that you need. Okay. And one step further that I just want to say is that part of this homeostatic system, like where it really occurs, where like its main effector place is, like its main action area is in a place of your brain called the hypothalamus. Okay, so your hypothalamus, it's the place in your brain that helps to keep things in homeostasis or in balance, like balanced more or less. Okay, your hypothalamus, it's also your drive center, where like our drive to consume food, obviously, but also to drink water, temperature regulation center that also is in your hypothalamus as well. But in a particular part of your hypothalamus called the arcuate nucleus, you don't have to know that, of your hypothalamus, that's where your like appetite center is. Okay, and you have like, I'm making two fists here because you have a part of your appetite center that's like what I call the eat pathway, right? Or it's called orexigenic pathway, the part of of that system, the types of neuronal pathways that make us want to eat, okay? And then there is the anorexic part of of this center, right? The part that makes us not want to eat. I know I just said a very loaded word here. In science, when we say anorexia, there is the eating disorder anorexia, but anorexia just actually means a loss of appetite. There's a clinical definition of anorexia nervosa, that's something else. But we all have a system in our brain that promotes that don't eat signal. Okay, so that's separate from anorexia. But individuals with anorexia can actually have changes in those brain regions, which is why they might have more of a drive to consume less. Anyways, that's super complex. We're not going to go down that path, but that's something for another day. Bottom line, your brain is set up in a way to help you maintain a certain level of nutrient intake and a certain level of fat storage to maintain health. Okay, that's your homeostatic appetite. The issue is is that most of us are influenced by that system, but there's a system that can override that like baseline level of appetite management. And that system that can override your like natural drive to consume, to keep everything balanced and keep everything more or less good, right, is what we call our non-homeostatic appetite regulation, right? So when we say this, what I mean is these are the things that cause us to overeat. These are the parts of our brain and the feedback systems from our body and also how we interpret our environment that cause us to eat beyond what we actually need to eat, right? So beyond like a healthy level, right? So this non-homeostatic appetite can lead to what we call uncontrolled eating. And there's lots of different words that are sometimes used as part of this that can be considered part of uncontrolled eating, like external eating. You could argue food addiction if you believe in it, but if you accept that term, it's not a universally accepted term, so that's another thing. But food addiction would be part of uncontrolled eating. Food cravings are part of uncontrolled eating. Something called hedonic eating or eating for pleasure, loss of control where it's really hard for you to stop. But even like binge eating could be considered part of this override of our body's natural ability to regulate body weight and energy intake. Okay. So in this episode, I want to unpack this because if we unpack these non-homeostatic factors that make us overeat, what we're doing is unpacking cravings. We're unpacking a little bit emotional eating. We're unpacking the factors that make it harder for some people to eat at a level that is going to promote health. Okay, so there are three main brain-associated regions or systems that are responsible for this like override. Okay, so it's not just one brain region that's involved in each of these, but it's just simple to kind of talk about them this way. So there's three main ways our brain overrides its own natural ability to manage weight. Okay, one of these pathways is something called the mesolimbic reward pathway. And this is the pathway in our brain that's dopamine-driven, right? Dopamine's a big word these days, but like dopamine's like the main neuromodulator that's part of this pathway. This is the brain pathway that makes us like want to seek out food. Like it makes us like, oh my God, I have to get food. It's what we call the wanting of food. You know, when you're like not hungry, you're not physically hungry, but you're like, oh my God, I have to, oh my God, I gotta get some food. I gotta eat this thing. And I can't stop thinking about it. You really want it and you might even move towards it. That probably has to do with the mesolimbic reward pathway. Okay. And we can technically override that drive with the decision-making part of our brain, our frontal cortex, in particular our orbitofrontal cortex and our prefrontal cortex, which is like the decision-making part of our brain. However, remember this episode's all about overeating in the brain. Some individuals have changes in their frontal cortex, which it makes it harder to exert this like executive control, this like, please stop, on top of like our natural drive to seek out rewards. And adding another layer of complexity to this, because why not? It's hard to unpack this fully, and the research isn't like black or white on it, but there's also the part of our brain that's concerned with like memory and emotions and fear and these kind of things that also have an influence on our desire to eat. And just knowing that emotional eating is a major issue for some individuals, that already kind of speaks to that. Some people eat not because they're physically hungry, but because they're maybe using food as a coping mechanism, right? And there's a neural correlate, there's a reason in the brain that is happening. So I just want to quickly, although it's hard to do this, unpack some of these pathways And I promise you that at the end of speaking of each of these pathways and how they work and how they can be compromised in certain individuals, I also want to give you some what do you do about it? How do you work with that? Okay, so part of this is the knowledge that these things exist and that brain chemistry and brain structure can show up as different desires to eat in different individuals. Okay, and then knowing that, and maybe forgiving yourself, because, we want to do all this from a place of fundamental self-worth, and you're already good enough and you're already okay. Knowing this, what can you actually do to work with your brain or set your brain up for success when it comes to eating behaviors? Okay, so first thing I want to talk about is that mesolimbic reward pathway, or the reward, or just the reward pathway. And like I mentioned, this has to do with the neuromodulator dopamine. Dopamine has often been associated with pleasure, and yeah, it can help us with the experience of feeling pleasure, but it's actually more about seeking out things that we have learned can provide us with pleasure. Okay, so for instance, you are not hungry and you are at a bakery, or you pass by a bakery and you smell the food in there and it smells amazing, and you have a memory of how amazing that food can taste. You might feel oh my God, I want that. I want it. I need it. You feel driven to go get it, even though your homeostatic appetite, you're keeping everything in balance appetite's you're actually cool. You're actually cool. You actually don't need food. Okay, so the reward pathway is potentially very strong in driving certain individuals to eat a lot more. And it's again hard to unpack the science of all of this and what the actual differences are, but we know that differences exist. And we really do see that with obesity. One of the main things we see in obesity is changes in this reward pathway, which might make it so that some people are more likely to feel that drive, that oh my God, I need to get this food right now, compared to other people. So for instance, I just want to provide some of the evidence to support this. And this is from an article called Widespread Reward System Activation in Obese Women in Response to Pictures of High-Calorie Foods. And basically what this article showed, and if you're looking at this on YouTube, you actually see the pictures of it, is that in individuals with obesity, there seems to be higher activation in these reward pathway associated structures, like the ventral tegmental area, or the VTA, or the and actually in other parts of the brain like the hippocampus and the insula and the medial prefrontal cortex too. But as far as reward pathway goes, actually the prefrontal cortex is part of a reward pathway as well. Really, the VTA is the big one that I want to speak to here, because the ventral tegmental area, this is one of the key areas involved in that reward pathway. And what this suggests is that you show an individual with obesity, a woman that has obesity, pictures of high calorie food, their reward pathway, the pathway that makes you seek out food, lights up a lot more than in someone that is in a smaller body, perhaps. Okay. And what that might feel like, the manifestation of that is oh my God, I have to go get that right now. Right? It might cause that drive to seek out that food more so than someone who doesn't have that same level of activation. Okay. And it's important to say here that it's hard to say what direction this goes. What do I mean by that? It's hard to say that if people are born with a tendency to have a higher activation in their reward pathways, that makes them seek out food and that makes them potentially increase their likelihood of developing obesity, if you got all that. Or does obesity and being in a larger body change the brain in a way where there is that higher activation when a person, for instance, sees an image of a high calorie food? And it's hard to really say, but at the end of the day, we know the reward pathways involved in driving food intake. Okay. Another piece of evidence to support this is in studies of individuals with binge eating disorder. They have found that the higher scores people that have higher scores on a binge eating scale, on a particular binge eating scale, they also seem to have higher dopamine release when they're presented with pictures of food. Okay, let me say that again. Okay. If I am someone that has binge eating disorder, and just quickly, binge eating disorder is it's a type of eating disorder. It's the most common eating disorder, and it's the eating disorder that's associated with binge eating. And binge eating is all about seeking out food, large quantities of food in a short amount of time, in a way that feels like there's no control. As someone who's dealt with binge eating disorder, it's hard to explain it, but it's like you can't stop yourself from eating. It's remarkable. And that's very neural. It's very like neurological what's happening there. You can tell yourself, I remember during binge eating episodes where I'm like, just stop. Okay, just stop. Just stop. Yeah, sure. And I would just keep eating. So my like thinking brain's ability to control and stop my binge eating was very, very difficult. But anyways, okay. In individuals with binge eating, higher binge eating scores are found in individuals that tend to have higher dopamine release when they're presented with pictures of food. And again, we don't want to over conclude from these studies either, but this is just another piece of evidence that there's some reward pathway associated brain system, maybe brain change, that's associated with a higher drive to consume food in some people compared to others. And taking it a step further and actually looking at mice studies, and I don't like to go to mice studies too much. This is from a study called Hyperdopaminergic Mutant Mice Have Higher Wanting But Not Liking for Sweet Rewards. Long title by Susanna Pezzini et al. Do I have the date there? Yeah, from 2003. This is a study that often comes up because what they did is they took these mice and they changed their genetics in a way where they overly express dopamine. So they have a lot of dopamine. Remember, dopamine, main part of the reward pathway. It's the main neuromodulator in the reward pathway. So they manipulated these mice so they have higher levels of dopamine. And these hyperdopaminergic, these super dopamine, hyped up on dopamine mice, they tended to seek out food a lot more quickly. Like they put them in these like mice trials where they had to like find the food. The hyperdopaminergic mice, that's a mouthful, were able to find the food way quicker. They were less distracted when they were seeking out the food, and they tended to eat significantly more and gain a lot more body weight too, right? So this again implies that there's something going on with the dopamine-related reward system that promotes higher food intake in some people compared to other people. Okay, so what do you do with this information? That's great. Okay, reward pathway is one of the things that makes some people eat more than others. So it's hard to say. That's why I believe so much in joyful experimentation, because you have to figure out what's going to work for you specifically. But one thing you might want to ask yourself when you're having those cravings is asking yourself if you're in a wanting pattern. And what I mean by that is there's a difference between wanting food and liking food. And it's actually shocking when you realize it. Well, at least it was for me. Like there'd be times where I'd be like, oh my God, I have to eat that pizza. I have to eat it. Oh my God, oh my God, oh my God. Like, and it's a consuming. And then I go and eat the pizza and I'm already full. So I'm not even liking the pizza as much. And again, sometimes I love pizza. So it's not like I don't like it, but sometimes we want, and we're not even getting the joy of it when we're having it. So part of changing our behaviors is pattern disruption and awareness too. Okay, so be aware of like, are you just wanting this food and not actually liking it? And what does it feel like in your body when you're like driven by that wanting, by that reward seeking? Okay, an option. And again, all this is joyful experimentation. What's gonna happen when I try these different things? What happens? An option is to distract yourself, is to try to do something else, maybe get outside the house, move around, maybe move those foods out of eyesight. Those cravings, right? Since we're talking about like chemicals in the brain, they don't often just stay high. There's like a wave of their presence. So you might want to ride the wave. You might want to realize that that wave might pass. And although you feel that strong, like, oh my God, I have to get this right now, if you waited 20 minutes, it might not feel as strong, which is again why distraction might be important. Okay. You might also want to try identify the situations where you feel that extra drive to consume, right? What are the triggers? What are your triggers that make you want to overconsume? What's happening? What's around you? Which environments are you in that are causing you to seek out that reward? Because what's happening is your brain saying like, oh, I know, I've learned that ice cream is rewarding. And now you're putting ice cream in front of my face. And so I am predicting that I'm going to get a reward from that ice cream. And if I don't actually consume that ice cream, it's going to feel terrible. Because my brain's like, I know that ice cream tastes amazing and I want it. And if you don't give it to me, it almost hurts. It's really interesting. Something called reward prediction error. Okay. If you're expecting a reward and you don't get it, it can feel really terrible, right? So what you want to do is maybe minimize the amount of rewarding foods that are around you so you don't feel that same drive, right? So setting yourself up for success might be part of that experimentation. And again, you play, you try things out, you see how it works, you collect data, you make revisions, right? No judgment, no shame, fundamental self-worth, finding your unique path. That's all part of this new weight paradigm. Okay. But that kind of gives you an overview of that reward pathway and how it can really cause us to overconsume food. So the second brain region, and again, it's not fully separate from the reward center, but we can think of it a little bit separately for our purposes here. But the second brain region that's involved with potentially overeating is something called the frontal cortex. Okay. And our frontal cortex can be further divided, but we'll just say that in general, the front part of our brain, this one's really involved in our goals and our plans and our decision making and our judgments, something that's sometimes called executive function. And when it comes to eating, we could use the concept that's related to the frontal cortex of what we call cognitive control. Cognitive, like brain, control, overeating. How much is like the thinking part of our brain, the part of our brain that we think of when we think of our brain, usually, like the part of our brain that we think is us. How much control does that part of our brain that we think we have control over actually have on our food intake? Okay. And what we will argue here over the next few slides is some individuals have changes in their brain that perhaps make it harder to exert this cognitive control, which you could call willpower, depending on how you're using that term, maybe. But some people have changes in their brain that make having this willpower, this control, this executive control over eating behaviors really difficult. And it might make some individuals, these brain changes might make it really difficult for some people to resist the urge, especially if the urge for food is coming from a really highly loud reward pathway, right? We're trying to override that reward pathway with our cognitive control. For some people, it's not as strong as for other people. And that is not a judgment. I'm really just talking about this like from a scientific perspective. This isn't like there's something wrong with you morally if you have lower cognitive control over this. Your brain just might be set up that way. Okay. So what I mean by this, and if you're watching this on YouTube, I have a picture from a paper from Physiology and Behavior, Neural Correlates of Dietary Self-Control in Healthy Adults, a meta-analysis of functional brain imaging studies. And what this one argues is that once we see food, let's say, we perceive it through our visual stream, okay, and the parts of our brain that interpret that, we then value that food. And part of what values that food is part of our brain that's associated with decision making, yes, and memory and other parts of our brain as well. But so we see food, we put a value on that food, and our reward system might get activated as well. But then the self-regulating part of our brain, this cognitive control, can override or double down on our decision making based on how we value that food. Okay, so for instance, so I am not hungry. Okay, so my homeostatic appetite is fine. I go to the whatever, I'm walking through the mall and I see the cinnamon bun stand and I smell it too. Let's just add another sense in there. So I sense and I perceive, smell and the look of something that I value, right? I know that there's an inherent value to those cinnamon buns because cinnamon buns are very highly, highly delicious, right? So I value that. And if I value that, I might just go and seek that out. And then where your prefrontal cortex primarily, or that thinking part of your brain, what that can do is override that. So for instance, if you've been like, well, I actually am trying to eat less, or, you know, eating that cinnamon bun really doesn't fit with my goals or my plans or my values, right? That cognitive control can be exerted to help you resist that. Okay. And that might make you not seek out that cinnamon bun, for instance. Okay. So that's the cognitive control, prefrontal cortex part of our brain and its involvement in seeking out food. However, what we found, or what studies have shown, is that in individuals with obesity, there's changes in the parts of the frontal cortex that are involved in decision making around food. And in particular, in individuals with obesity, there's lower overall prefrontal cortex activity, which means that maybe it's harder for them to exert that executive control. And they tend to have lower activation in something called the dorsolateral prefrontal cortex. Okay, so these are like from brain imaging studies where they like get people to, like, it depends on the study, but they often get them to look at pictures of food or give them food, and then they just see how the brain responds, what parts of the brain use the most energy, which suggests that there's more activities in those parts of the brain. Okay, and so what they found is that individuals with obesity, in the areas of the brain that tend to be associated with exerting the cognitive control to lower food intake, there's lower activation in those. And again, is it that obesity is causing that? Or is it that these changes are more from the start line and those changes are causing people to eat more? Okay. Also, in individuals with obesity, they tend to have less gray matter in the part of our brain, the orbitofrontal cortex, which predicts how rewarding food will be. So the point I'm trying to make here is that, because we're talking about overeating in the brain, and I had to start with the reward pathway, because that speaks to cravings, and that speaks to why some of us are so driven to consume food compared to other people, and especially within certain situations. But one of the things we have to help override that reward pathway is our cognitive control, is our thinking brain, our judgment-based brain. But in some individuals, it's just not working at 100%. Again, that's not a value judgment about them as a human. We're all innately valuable. We're all good enough. We're all worthy. But my point is that it just makes it harder for some individuals versus others to resist some of those temptations. Okay. And to add another layer to this, which I think is just such a fascinating study. I don't know if you've ever heard of these like delay of gratification studies that they did in the 60s and 70s, where they took like preschoolers and they basically told these preschoolers, like, you can have a reward now, or if you like, you can have a cookie now, or if you wait a certain amount of time, the longer you wait, like the more of a reward I'll give you. Okay, so for example, an example of this test is like, okay, sit in this room by yourself. There's a cookie in front of you, right? If you eat that cookie, it's done. But if you wait longer, I'll give you maybe 2 cookies, right? Or they also run the studies in like the longer you can resist before you ring the bell, you'll get a cookie when you ring the bell. The longer you can resist to ring the bell, or try to resist it as long as possible, you'll get a better reward. Okay, so that's delay of gratification is what that's called. How long you can delay getting a reward. And so what's interesting is they found that certain kids, they want the reward right away. I was definitely one of those kids, like, give me the reward right away. I want it. I don't want to wait. I don't want the bigger reward in the future. I want it right now. But what they found is in those kids that couldn't delay gratification at age 4, when they followed them forward through time, they found that those kids that weren't able to resist those rewards at that age were actually much more likely to have a higher BMI than kids that were able to delay gratification. Okay, so here's part of the research study. So this is from Preschoolers' Delay of Gratification Predicts Their Body Mass 30 Years Later by Schlam et al. Oh man, again, I don't have the, oh yeah, it's from 2013. And I'll read you I'll just read you the study design. In the late 60s, early 70s, 4-year-olds from a university-affiliated preschool completed the classic delay of gratification test. As part of a longitudinal study, a subset, 164 people, were followed up approximately 30 years later and self-reported their height and weight. Okay, what did results say? Performance on the delay of gratification task accounted for a significant portion of variance in BMI, over and above the variance accounted for by sex alone. Now, here's the big one. Here's the big result. Each additional minute that a preschooler delayed gratification predicted in a 0.2 reduction, a 0.2 point reduction in BMI. So instead of a 1 point, a 0.2 point, sorry, that gets a bit confusing, reduction in BMI in adulthood, which basically means that kids that were able to delay gratification the most were most likely to be thinner, more likely to be thinner when they got older. And my question here is, are we really saying that there's something wrong with these 4-year-olds? Are we really saying that there's something wrong with a 4-year-old that can't delay gratification, and there's something inherently better in a 4-year-old that can delay gratification? Or is there something going on differently in brain chemistry? Or is there something going on differently in other ways that person has been programmed? But something's going on that starts at a young age that makes it harder for some people to resist temptation than other people. And I don't think this is something that we need to feel bad about, but it might just be the way our brain's structured. And then the question is, how do we work with that? Okay, which brings us to some take-home messages about this area. Okay, so a few take-home messages about cognitive control and overeating, our prefrontal cortex and overeating. So one thing, it's great to make plans, and it's great to have a dietary plan or an exercise plan, but that might not always be enough. As you probably know, as I've experienced myself as well, I've created many plans for myself over the years, and I'm really great at them for the first week. Excuse me. But then after a while, that behavior becomes more and more difficult as my life becomes more complicated, as stress goes up, as other things happen, as life invariably unfolds, right? So it's great to have plans, but they might not be enough to help you, if you're trying to eat less, eat less. That's why I really believe in setting yourself up for success. That's why I keep saying that. Do you need to minimize temptations in your environment? Do you need to realize the things that are ultimately rewarding and that you have a really hard time resisting? And you have to, again, change your environment or change your response to those triggers so they don't affect you as much. Okay? Something to keep in mind is that a lot of people talk about willpower, and we're kind of in the concept of willpower here. It's often not enough, and willpower can be exhausted. So for instance, actually, you know this, you don't need research to tell you this, right? In the beginning of your diet, it's really easy to make good decisions. But the more good decisions you make, the harder it is to keep that up. And they've actually seen that in psychological studies where they ask people to do tasks in the beginning of the day that require a lot of willpower. And they ask them to use their willpower a lot. And by the end of the day, their ability to make quote unquote good decisions goes down, right? We tend to, the more we just rely on willpower, the more we exhaust that. And that's why skill power is something that's suggested too. So that's like setting yourself up for success, right? How do you minimize the triggers in your environment? How do you create the situations that help you make better decisions? So for instance, if you're trying to eat more fruits and vegetables, keep more fruits and vegetables in your home, right? That sets you up for success. Something else that's part of this cognitive control part of overeating and how we can manage overeating is that the research I present didn't really speak to, but other things I've talked about do is this concept of values-based goals, right? So what do you value truly? What is important to you truly? Why do you want to lose weight? Not just to look a certain way, but maybe you want to eat less because, that's going to help you get to a body size that allows you to spend more time with your family, that allows you to travel more, that allows you to feel more comfortable in your skin. You need to have a strong why, because when those temptations pull up, and they will, and it's the end of the day and your willpower is all exhausted, that's one of the things that can maybe help you with cognitive control, right? So when I was trying to quit, for a long time, I had a really significant night eating habit where I would eat dinner and then 10 p.m. I would eat 25% of my daily calorie. It was terrible. I did that for a long time. When I was trying to quit that or manage that, it was really hard in the beginning because I was used to that getting a reward at 10 p.m. I was used to it's 10 p.m. I get a food reward. I'm used to that. And now I'm not giving myself that reward. It feels terrible. It feels terrible, right? So to get me through the beginnings of changing that behavior, I really had to double down on my why is it important that I don't do this anymore? Why do I care? Well, I care because I'm eating well and I'm exercising, and this eating at night is compromising my values around how I eat and how I move. And it's leading me to feel really tired. I feel bloated and not so great the next morning, right? And I don't want to feel that way anymore. So it's you almost have to, you need that angel devil system on your shoulder, if you want to call the devil. I don't like calling it the devil, but anyways, if your drive to consume beyond your needs is the devil, you need the angel there to talk some reason into it. Okay, so I don't believe you can rely on any of these things alone, but it gives you some ideas. Okay, and then notice your defaults. What are you defaulting to, and how can you break those patterns? Okay. Lots to cover when we talk about overeating in the brain. And the last area, which is even harder to unpack than the other ones, and the research is kind of all over the place, but I don't think it's surprising to anyone that for some people, what's driving them to eat is what's going on with their feelings, what's going on with their emotions. And some people, food is rewarding. It feels really good. You get a ding, 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 yeah, when you consume food. And so if you're not feeling great, you're having a bad day, right? You're in an emotional wave, the high end of an emotional wave. It makes sense that you might seek out food to make you feel better, right? So emotional eating is a tendency to overeat in response to negative emotions, such as anxiety or irritability. That's Van Strien 2007's definition, right? In response to negative emotions, emotional eaters are more likely to consume foods higher in energy, fat, and sugar. That's something that Alfeg and Rossner 2005 found as well, right? So there's something going on with certain people and their emotions, which isn't just a brain thing, it's also a body thing, because our body and our brain talk and they're all related. That's why it's so hard to unpack this information. But there's something going on in our brain that's not making us feel great in a particular moment or maybe there was some sort of trigger, someone else made you feel bad, or you got bad news or whatever. And some people in that moment will seek out food as a natural comfort. Other people seek out drugs. Other people seek out alcohol. Other people seek out their phone, right? We look to things that make us feel better when we're maybe not feeling so great. Okay. And so there's, like I said, the research is all over the place, but just a couple studies that help to support this. And this one's from the journal Appetite, which I love, 2022 study that stress-induced alterations in the HPA axis reactivity and mesolimbic reward activation in individuals with emotional eating. And basically what this study found is that in people with emotional eating, there were differences that were seen in activation in the reward centers. So something's going on in emotional eaters that might make that desire to seek out rewarding foods more desirable than in other people, right? And that makes sense. When I'm like feeling sad, food makes me feel better. I'll be just straight up. Food makes me feel better when I'm feeling sad. And it's not chicken that's making me feel better, like chicken's delicious, don't get me wrong, but it's usually like high fat, high sugar, right? Sometimes salty foods that feel particularly rewarding. And in people with emotional eating, the desire to seek out those foods might feel even stronger. That said, in this 2018 review in Neuroscience and Biobehavioral Reviews, a study by Catherine Evers et al., they kind of looked at the literature. It was like a meta-analysis of experimental evidence. They looked at the literature and they found that it's really hard to say, like, do bad emotions make you eat more? Like, do good emotions make you eat more? Do they make you eat less, etc.? They looked at the literature, and what they basically found is it's all over the place. Some people, when they're going through an emotional moment, they tend to eat more. Some people, when they're going through an emotional moment, tend to eat less. But there's something going on for some people, right? And someone who identifies maybe as an emotional eater, they will tell you how strong that feels, right? And even though the evidence might not fully capture that, we can't dismiss those experiences. They're very, very, very real for some people, right? And so, again, some take-home messages, some things to think about when it comes to this one area of the brain, this one kind of response of the brain that's related to the brain that might make us overeat, is what's triggering you in the moment? If you're eating beyond your body's needs, what's causing you to do that in this moment? Are you using food to cope? And can you forgive yourself for that? Because it's totally normal and very common, and we're not told, we're not taught how to deal with our emotions, and no one gives us a rule book for life, right? But are your triggers, are you responding to your triggers in a way where you are using food as a coping mechanism? Right? How are you using food? And is there something else you can use instead of food, that's healthier? Or is there a way for us to decrease maybe our emotional response to that particular trigger? And I'm exhaling here because I'm very cautious of my wording, and I'm worried about saying it the wrong way. The point I'm trying to make is, we're not taught emotional regulation. We're not taught nervous system regulation. We're not taught how to deal with the crap, the shoot that is living a human life, right? But there are ways to manage those emotions, right? Getting out in nature, talking to friends, journaling, crying, moving your body. There's lots of different ways to manage your emotions. Can you figure out what's going to work best for you? And also, I find that some people, they really judge themselves for being emotional. And I think being emotional is a beautiful thing. I'm actually not that emotional of a person. And unfortunately, that means I'm not as sometimes wise about emotions as other people. And I don't I don't get the benefits of really feeling through things the way other people do. Like melancholy has some beauty to it. Some people are just a little more melancholic than others. And that's not something to judge about yourself. It might just be the way you're set up, right? Perhaps because of your experiences, perhaps because of the way your body is structured, right? So can we ride those melancholic waves? Can we accept them as part of our human experience? Or do we always need to numb them? And that's what we're often doing with food or alcohol or gambling or video games or our phones, etc. We're trying to numb that experience. But there's a lot of wisdom in feeling your emotions too. And, is that just part of your experience with this world? I don't know. Something to think about this, because I don't think there's anything wrong with being emotional. I think it's a super beautiful thing. But then how are we, when we're having this emotional wave, how are we responding to it? And are we responding it to a way that compromises our goals and our values? That's something we want to think about, right? And how can we regulate those emotions in a way that actually makes us feel better and that doesn't mess with our physical or mental well-being? Okay, so overall, some main messages from today is that our brains are not structured the same way and they don't function the same way. That's one of the fundamental messages about human existence and humans in general, is that we are all very different. Heterogeneity, as we say, right? We're just different. Okay, so your brain's going to work differently than someone else, which means that the ways to work with your brain with respect to eating behaviors or exercise behaviors are going to be different than someone else too. Okay, that's why it's so important to figure yourself out. That's why just a key part of the new weight paradigm is about finding your unique way and joyfully experimenting to figure out a path that's going to work best for you at this present moment. And then when things change, you joyfully experiment again and figure out what's going to work for you again. Right? So work for yourself, set yourself up for success as much as possible. And like I keep saying, joyful experimentation is part of the game here. Okay. And as always, I'm always going to come back to the same message, which is you don't have to change yourself in any way to be enough, to be good enough, to be worthy. You're already worthy. You're already good enough. I'm happy you're in this world. So are the people around you, the people that you shine your light with and that get to experience your amazing aura. And if you decide to change your eating behaviors and your exercise behaviors, awesome, go ahead. But do that from an informed place and do that from a place that really considers who you are individually and how different that is from other people, right? And work with yourself as opposed to working against yourself. Okay, and make sure whatever things you decide to do don't mess with your mental health. That's pretty key as well. Okay, so thank you for listening. My name again is Deanna Bedoya. If you like this podcast, if you like these YouTube videos, subscribe, like, buy me a coffee if you really want to, write a review, share it with whoever you think is needing these messages. And if you're looking for more personal coaching, reach out to me as well. I do that. I don't advertise too much about it, but that is something that I do as well. So that might be something that you need for you to help you find your own unique path to feeling amazing in your body. Okay, so thank you for listening to the New Weight Paradigm, and I will see you in the next episode.